discussion. All right, welcome everyone to the Hawaii Aquaculture Tech and Research Brown Bag, sponsored by NELHA and the Hawaii Aquaculture Collaborative, which is facilitated by the University of Hawaii Sea Grant College program. I'm Jean Schneider on the facilitation team with Keith Olson, Kai Fox, and Cherie Kawahi. The recording of today's session and slides will be posted on our website, hiaquacollab.org. Please let us know you are here in the chat and use the hand raising feature or the chat to ask questions and make comments during our discussion. This is the Technology and Research Working Group of the Hawaii Aquaculture Collaborative. The purpose is to provide a space for Hawaii aquaculture industry leaders and stakeholders to collaborate on technology and research solutions. Our format is about 10 minutes of background, context, and a problem that an industry leader is trying to solve. The rest of the time will be for questions, discussions, and possible solutions. Our schedule is every second Wednesday of each month at noon. If you have an aquaculture tech and research problem you'd like to solve, please contact Kai. And for more info, please see our website. Brief announcements. In other collaborative news, we were trying to plan a summer meeting focused on workforce development. However, our education partners have been transitioning from summer to back to school, so we're giving them some breathing room. We are trying to secure faculty from Windward Community College to speak about a new upcoming aquaculture technician program. So more on that soon. On the employer side, our industry partners continue to indicate a need for an aquaculture workforce, and you can link to some available jobs on our website. We've been in discussions with Senator Dela Cruz's staff on support needed from policymakers and government partners. They've provided some valuable feedback and resources, which we are compiling. And we're excited that the Department of Ag has finalized the State Aquaculture Development Program strategic plan for the next 10 years. We will be forwarding that to you in our next communication. And on the communications front, the recording of the keynote and panel discussion of What's the Catch? Cultivating Hawaii's Seafood Future is also linked on our website. And now let's get into our main event. Over the next few months, we'll be focusing on projects to produce local feed. Feed and the importing of feed to Hawaii is one of the costliest inputs to our aquaculture and livestock farming industries. Hawaii has been trying to solve this for decades. Can feed be locally produced to reduce imports and shipping costs, reduce our carbon and landfill footprints, and to create economic and workforce opportunities? Neil Sims is going to kick us off today with Sashimi with a Softer Footprint, Sustainable Feeds for Farming Marine Fish in Hawaii. Neil Sims is the CEO of Ocean Era and is committed to softening mankind's footprint on the seas. He's worked in fisheries management and development in the South Pacific throughout the 80s and has been based in Kona since 1990. In 2001, he co-founded Kona Blue Water Farms and developed cutting-edge hatchery methods for difficult to rear marine fish, and pioneered the first integrated hatchery and open ocean fish farm in the US. Welcome, Neil.
Thank you very much, Jean. And if I may share screen here.
Yes, please.
Two things, first of all. One, 10 minutes. I don't think anybody that knows me has ever seen me just be 10 minutes at an open podium. And the other is I'm a little bit distressed. Greg is sitting over there eating my lunch, I think. He hasn't given me my sandwich yet, but I'm sure it's coming. He's holding it. But aloha kako, thank you all very much. I will try and keep this as brief as I can, but I want to focus on the alternative feeds research and development that we've been doing at Ocean Era, which was previously named Kampachi Farms. And then to look at the potential for local aquaculture feed production here in Hawaii. So let me just move this one side, I'm sorry. So our mission, the goals that we have, the mechanisms that we have to address this mission, which I think we all of us involved in aquaculture share this sense of the imperative here. And we're focusing here on developing offshore macroalgae culture systems through a couple of programs funded by the US Department of Energy and also WWF. We're working on alternative scalable feedstuffs for carnivorous marine fish. I say carnivorous, but they don't really need to eat meat. They just need a diet that is high in proteins and lipids and low in carbohydrates. That's fish such as the moi or the kampachi or groupers or snappers or mahi-mahi. We're also working with culture of marine herbivorous fish such as the nanue or the chubs, as they might know them on the mainland. And then we've also, because we see that a lot of the constraint for the industry is regulatory, and we have some experience with the permitting for offshore aquaculture. We are working on in a number of different areas there on pioneering, blazing the trail essentially for marine fish culture in US federal waters. And so aquafeeds, we like to think of this as magic. Essentially what happens with aquafeeds is that you take these diets and you turn them into sashimi. Yes, you do need the fish to make this all happen. But whilst it's this part of it is magic, there's also this critical need that you have to be able to do it in a way that is profitable. And importantly, for a lot of the alternative feedstuffs out there, it needs to be scalable. And then it also ought to either enhance your market access or not impinge your market access. So enhancing your market access might be reducing your fish in, fish out ratio, or your forage fish dependency ratio, which would be important for one of the certification programs, such as a BAP or ASC. But then there are also some segments of the market, such as whole foods, which are resistant to some feedstuffs, such as land animal proteins in the diets. We've worked here over the years. Kampachi Farms was about 2010. We started working with alternative feeds development. We'd already done some prior work with Nebraska soybean board there, but we've continued on that work with looking at soy protein, soybean meal, which work reasonably well, but only up to about 20% inclusion levels, soy protein concentrate and soy protein isolates, SPC and SPI, and then soy oils. We've also worked with fish peptide concentrates, which are essentially what you filter out of the waste processing water from fish processing plants. We've done work with a range of different microalgae with varying degrees of success, including working with our partners here at Nelha Cyanotech and with their spirulina. We've done some little bits of work with single-celled proteins, which is essentially what it sounds like, bacteria or coming out of a fermenter or a digestion plant there. We've done some work with poultry byproduct meal, and we're also starting to do more work with macroalgae, or limu as it's known here in Hawaii. Some combination of these, we think, is where the future really lies, to be able to, when we say soften humanity's footprint on the seas, the biggest lever that we see here is to be able to reduce the fish meal and the fish oil inclusion level in the diets of these marine fish. Some of the earlier work that we've done, we've had about 13 years of work supported by the Nebraska Soybean Board, looking at, as I said, the SPC, or the soybean meal, or the soy protein isolate, or the soy oils. And this had culminated, perhaps the best performance that we had here was in 2015, with a diet that was around 40% soy protein concentrate. We're able to lower the fish meal level there from somewhere around 20 to 30%. We don't know because it's a commercial diet and they weren't disclosing what that level was, but we got it down to about 12% fish meal and 2% fish oil by being able to use a soy oil that was stearidonic acid enriched. Stearidonic acid is one of the precursors for the long chain fatty acids there. So this graph here shows the commercial control over about a month grow out trial here, the commercial control curve there in black, and then the soy protein concentrate stearidonic acid feed there in the green line there, which had actually pulled away from the commercial control diet there in the last couple of months. This was really encouraging for us. This is marrying America's blue horizons with her heartland to tie in with the soybean industry there. There was no significant difference in weight performance here, the final weights. And then when we looked at the feed conversion ratio, even though you squinted that and you might like to see a difference there was statistically no significant difference there between the commercial controls and the soy diet. And critically, one of the things that we frequently do when we're running Kampachi feed trials is that we ran palatability tests in here. We partner a lot with Oregon State University. They've got a food technology lab there, and they are able to go and do extensive controlled trials here with trained sashimi tasting panels. I don't know how you get onto a trained sashimi tasting panel, but that's a job at some stage that I'd like to elbow my way into there. And again, significantly, there was no significant difference here in the flavor profiles, the overall preferences between the commercial diet and the SBC, the tofu diet, essentially, as you might call it. And so then, as I said, we'd also run some, sorry, just to make sure where we're going there. Yep, we're good. We'd also run some trials with single-celled protein. So these are essentially a bacteria that you can run in a fermentation plant or a biodigester, and you can feed it corn oil or soy oil, and it will produce what this company here is producing, what they call NIP bio meal. NIP is pink spelt backwards. And this was a trial here that we ran over a 4-month period, looking at the growth performance again with Kampachi. And again, there was no significant difference here. So you could replace 5% of the fish meal with the NIP bio meal, and it didn't affect the performance there on the fish. And again, looking at the difference in taste or texture, there was no significant difference there, no detectable difference there. More recently, we've done some work with Dr. Rick Barrows. This has actually started back in 2013 when we had some funding from NOAA through their Saltonstall Kennedy program to try and reduce the fish meal level in the Kampachi diet. And Dr. Barrows had said to us, well, you know, you could eliminate it entirely if you wanted to. Those who know Dr. Barrows, he doesn't mess around. When Rick says something like this, your ears perk up and you pay attention. And so he was able to formulate this diet here that was based on a poultry meal. This is essentially the part of chickens when you pull out the thighs and the breast and the drumsticks to feed that goes into the commercial markets. There's lots of other parts of the chicken that we don't eat so much, and so this is perfectly fine. Chicken is what we like to think of as upscaling the processing byproducts of poultry there. This was just a food grade. Sorry, it was not just a food grade. This was a food grade. So this is what would go into like a pressed chicken sausage or something. And so even though the performance of this poultry meal diet compared with the commercial control, so there was no significant difference between those, it was very expensive. And so it was not going to be something that would gain commercial traction. And one of the things that we like to think we focus on in Ocean Era is that our research has to be focused on what we call the critical commercial path. Yes, we occasionally do publish scientific papers, but that's not the goal of what we do. What we want to do is to have the commercial producers, Dick Jones and the Hawaiian Kampachi, we want to have them take up the diets that we are doing the research on and make a difference, because otherwise, why are we doing this? So with a really expensive food grade diet that wasn't going to work. We came back again with some additional funding from Saltonstall Kennedy later to say, well, let's look at a feed grade. And so this is what would normally go into food that, I don't know, people feed their pets. I can't understand why, but I suppose if you feed your cat with something out of a can, at least it's not going to go and eat the small birds in your garden. But this feed grade, less expensive poultry meal, and the performance initially over the first couple of months, there was no statistical difference. In the last month, we saw a really disappointing falling away in the growth performance here. And initially, we were perplexed by that. We ran some trials looking at the peroxide levels in here, which is an indication of the oils. What happens often here in the tropics is that if a diet is left in a warm environment, that the oils will go rancid fairly quickly. And you need to have those oils stabilized. What we hadn't done in this diet here was to be able to effectively stabilize those oils. And so we had very high levels of rancidity there. The standards are that if you're at about higher than 10 in terms of the PV, the peroxide value, if you're around 10, you should replace the diet sometime soon. If you're around 20, you should get rid of it immediately. The levels here are up around 63 for one of these diets. And so that's one of the things that we find is really challenging in running these trials, to be able to keep the experimental feeds stable. Again, however, the growth performance had fallen away a little there, but when we ran the palatability trials here, the initial test that we did showed that there was actually a preference again for the Kampachi that had been fed the poultry meal compared to the Kampachi that was fed the controlled commercial diet with the fish meal in there. And we ran some secondary trials again, because this was so astonishing for us. We ran some additional trials here. And again, it confirmed that the poultry meal, the preference, and this was in a two-way blind taste test, the fish that were fed the zero fish meal, zero fish oil diet were preferred. This work was also, hats off to the F3 network. Those of you that are interested in working in the alternative feed space, you should reach out to the F3 folk. They're based out of Silicon Valley. Fish Free Feeds is the F3, and they're very eager to support this sort of work at a number of different levels there. So we had this feed grade meal. Now we wanted to look at the commercial viability of a diet such as this, and this was the F3 folk have a feeds calculator, if you will, on their website. Too complicated for us, so Dr. Barrows ran this for us, and the cost of goods that would go into this diet here around at the time that we ran this, around $1,700 per ton, versus the commercial control would be around $2,200 per ton. And that's the zero fish meal, zero fish oil diet there. These prices weren't really what you could get if you were a feed company of the likes such as Cargill or Skretting or Biomar, and you had the purchasing power to be able to bulk order bulk containers of these products at a time. So this is really encouraging, and we're pleased to be able to move these trials further forward with some of our research partners here at NELHA. And those trials are currently underway. But I want to just stop here now and look at what we can conclude from this work that we've been doing over more than a decade here now with the Kampachi. And we think the Kampachi, as a very fast-growing fish that has a very rigorous clientele, very different, because it's a sashimi-grade product, very high-quality product. We think that this is a great model to be using as a test for the carnivorous fish species. And so the conclusions we think here are really exciting. The fact that the number of alternatives that we have here, soy protein concentrate and soy oils, and to some extent single-cell proteins at a smaller inclusion level, and then poultry meal, and then also Veramaris, which is the DHA-rich oil that's being produced by a plant in Nebraska, and that's coming from, again, a single cell. It's sort of a cross between an algae and a fungus that just pumps out. You pump in corn oil on one side and it pumps out DHA on the other. And so these are all eminently scalable, as I'd spoken of earlier. And the conclusion of this, because we are so often criticized as an industry that is just feeding fish to grow fish, no, you no longer need to feed fish to be able to grow fish, that we can scale up this concept of softening our footprint on the seas, that for most of these products that they would meet the certification targets, they're marketable. As I said earlier, the poultry meal, some of the potential markets have issue with land animal proteins. It is, to our rudimentary assessment here, it is cost competitive and it is preferable from a consumer taste profile. So we're really excited about this because this work has been supported up to now by Salt and Still Kennedy grants and through the F3 network. It is all public domain. And so if you're interested in more of this information, please do reach out to us or to NOAA or to the F3 network. So that's the work on Kampachi. I want to also just touch on the work that we've done with herbivorous fish, the Nanue, and then I'll get to the questions that we might discuss here. But we've been interested in Nanue for 12, 13 years or so. Very early on when we'd started the work, thinking about how we might be able to turn the carnivorous fish, such as the Kampachi, into herbivores, we felt like it was an obvious question. Well, why don't we go and also just try and farm some of the herbivorous fish? And on a coral reef, most of the larger fish that are out on a coral reef aren't carnivores, they're herbivores. You think about the Nanue or the Maiko, the Kole, the uhu, the parrotfish, the surgeonfish, most of them are herbivorous. And they're considered, to those of us that have spent time in the islands, they're very high quality. The kyphosids, the Nanue or the rudderfish or chubs, are considered one of the target fish for poke here in Hawaii, and they make a living off seaweed. This is it. Essentially, they're a machine that turns seaweed into sashimi. And we like to think of them as, well, actually, our trials have proven this out. You can feed them a tilapia diet and they will taste like a snapper, perhaps even better than a snapper. This here is an initial trial that we had done over a 6-month period. This is days across the x-axis across the bottom. And this is looking at a tilapia diet versus the yellowtail diet or the Kampachi diet here. And they perform just as well on the tilapia diet, which is a lot less protein and lipid and a lot more carbohydrate, as you would expect. This is an animal that makes a living eating plants. They should do pretty well on a tilapia diet. The feed conversion ratio, for those of you that have a fisheries background, this is really where the commercial rubber hits the road. Growth curves are nice, but what you really want to figure out is how efficiently your fish is converting the feed into flesh. The feed conversion ratio here was higher than what we would have liked to see, but it's an herbivorous fish, and so the tilapia diet, it's around about 40% the cost of a Kampachi diet. And so this, as an initial FCR for just testing a diet, this is fairly encouraging. And then when we ran some tasting trials here ourselves, sometimes, yeah, okay, we're not trained tasting panels, but occasionally we do sit down ourselves and eat some lashings of sashimi or poke. All in the interests of science, you understand. 60% of us performed, and this is in a blind tasting study, 60% preferred the Nanue that were fed the tilapia diet versus those that were fed the Kampachi diet. And then we'd also run some trials here where we think, well, are there some other innovative diets that perhaps are even less expensive than the tilapia diet? And so this was, again, working with Dr. Rick Barrows, the man is a maestro at this sort of thing. He had tracked down a source of duckweed, dried duckweed, which is, it's used at the moment. It's grown for the human food market. It's a very high protein, but it's an invasive freshwater, weed. And so it overruns lakes and ponds all over the mainland. We don't yet have it here in Hawaii. We would never propose to grow it in Hawaii. But if they have it as a problem on the mainland, then there's potential for somebody to be harvesting this and making a feed grade duckweed protein. This was at 80% duckweed and 20% wheat flour, and it performed as well as the tilapia diet. So that's really exciting for us here now. So what are we doing with the Nanue? We are starting, as I said, we do look for commercial traction for our work, and one of our basic areas of focus is pioneering the permitting. And so we are moving forward with a permit application for a farm site that would be doing both moi and Nanue and limu on offshore Ever Beach. So very close to where there was formerly the moi farm site offshore of Ever Beach. And our concept here is that you'd be able to grow the fish in the pens up current and then grow the limu in the lines down current of these. Perhaps in the limu that you're growing, you could also use to feed back to the Nanue. So you'd be able to reduce the cost for the diet to the Nanue. And then you're getting the effluent from the fish that is stimulating the growth of the macroalgae, the limu. And so then that could also be sold into the Oahu market there. Yes, we'd love to be doing this on the Big Island, but there's 1 million consumers on Oahu. There's 180,000 here on the Big Island. So this is where we'd like to be focusing initially. We're just about to submit the permit applications for that site. One of the other questions, 10 minutes, okay, it's 20, Gene. So give me another 3 minutes, please, Gene. One of the other questions that we've had here is, okay, Nanue are really good. As I said, it's turning seaweed into sashimi. They do this really efficiently. How do they do that? When we talk to folk that look at fish digestion systems, and bless them, there are folk that spend their lives, their whole careers are based around fish guts. They will say it's not the fish itself. The fish is producing very little. The fish will produce acid, but they won't produce enzymes. It's all the microbes that the fish has in its gut. And so one of the propositions that we took to the Department of Energy is, the Department of Energy is very interested in looking at macroalgae seaweeds as a potential biofuel, or as a way to also be decarbonizing a lot of the other sources of animal feeds. And so we said, this here is a beautiful model for how you can go and break down seaweed into usable products. Let's go and try and figure out how the Nanue do this, find out what is the key elements of that microbiome, and then see if we can scale that up. So we've been doing some work here, partnering with Scripps Institute at University of San Diego, with University of Hawaii Manoa, the Lawrence Berkeley Lab, and the National Renewable Energy Lab. We've been looking at initially trying to see if there was any methane that we could produce, any methanogens in the bacteria there in the Nanue guts. No, but then are there other microbes that we could just be breaking down? Seaweed is full of complex polysaccharides that are big, long molecules of carbohydrates tied together. And so what the fish is able to do with its microbes is to break those down into more digestible metabolites that then the fish can absorb through its digestive tract further down. And so that initial breakdown of the seaweed polysaccharides, can we co-opt that and then use that partially digested macroalgae or partially digested seaweed? Can we feed that to other animals and then reduce the carbon footprint for these other animal feeds? So we thought, looked at the whole spectrum of potential fish and land animals that are out there, and we thought of this on the y-axis there. You see, well, the market size, the current market size and the value, and therefore the potential impact. But then also, if you're breaking down seaweeds, what's the likelihood on the x-axis? What's the likelihood of this actually working? So obviously, for kyphosids that are already doing this, very likely to work, but there are very few people that are doing herbivorous fish. For the Kampachi, for example, less likely to work because they're very fastidious about their feeds, a smaller market size. For something like poultry or swine, huge market potential. We're not really sure yet there about what the likelihood of technical success. What we focused on initially, so there are three goals here. One is both replacing the feeds there, such as distillers' dried grains or other things that are used to replace the feeds in there. The others potentially is an immunostimulant to increase the animal's immunity there, and then also to reduce the carbon intensity. When we looked at all of this range of potential species, we thought, well, let's use tilapia as essentially our white mouse here. It's a fairly significant market size, 6 million tons per year grown globally, and they are themselves an herbivorous fish. So this partially digested seaweed may be able to work as an inclusion in their level. We've been running some trials here with 10% of the tilapia diet being the padma, and it's been working very well so far. We're really encouraged by those initial results. We're wanting to next go and test this out in shrimp and in fish such as the Kampachi. So that's where we think this work might lead to. Through seaweed, it could be profitable, scalable, because there's millions of tons of seaweed grown around the world. The challenge there is what you do with it. And if we can find a way to convert this into animal feeds, that'd be really encouraging. And then the market access, everybody loves seaweed. They don't want to have to eat it themselves. They want their fish to eat it, and then they'll eat the fish. So the questions that I want to posit to the group for broader discussion, I'm getting the hairy eyeball from Greg, so I have gone on way too long. But now, having worked here in Hawaii now for 32 years, I think we want to take a realistic approach to what it is that is possible for us to do here. We are the most isolated archipelago on the planet. So that means our shipping costs of feed from the mainland are really expensive. But then with Senator Dan Inouye, who had in the 1990s had stated with quite some pride that Hawaii has the highest paid agricultural workers in the nation. That's great if you're an agricultural worker. If you're trying to produce feed for your animals, then that's going to make that feed fairly expensive. So I think we are interested in this question about what feedstuffs, and that's the stuff that goes into the feed, where might there be long-term competitive advantages? And obviously we're big fans of the seaweed for the Niue or for the Padma. We've also had some discussions with Pacific Biodiesel about using mac nut processing products or dehulled sunflower products. Something like that might be useful, but it's got to be, again, it's got to be profitable and it's got to be scalable. And so, papaya seeds, great, but I don't really see the scalability of that. And if it's not scalable, you're not really going to have the commercial advantage. You're competing with Cargill and Skretting, who buy fish meal by the bulk carrier load out of Peru. So we've got to ask ourselves, what scale does it make sense to produce feed locally? There is a feed mill that Oceanic Institute had built over in Hilo that is, as I understand it, a great feed mill, but I don't think it's had really some commercial traction because it's big. And so it needs to have a lot of feed going through it to make it commercially viable. And I think a smaller experimental feed mill might have perhaps been more useful, such as Oceanic Institute used to have one there now. And Armando Garcia at Hilo has been very generous in using his pelletizer to be making some of the feeds for us for our Padma trials. But is there a scale where we could be making feeds where it made commercial sense? And if so, who's going to fund that? It's got to be, you can't be reliant on the public purse, even though we do have the director of the Office of Finance, the chair of the Finance Committee here with us today.
Yes.
We're not, maybe this 1 year or this 2 years at the legislature, we might be able to get some money to help move this along. But we've got to look at long-term commercial traction. What is going to really work here? And then who would fund this? Everybody likes to say, well, Pierre Omidyar will fund it. Well, for how long is Ulupono going to go and fund this sort of work? It has to be something that would have some commercial traction in the long term. But then there's also the question then, okay, for commercial scale, there are those questions, but then at a smaller scale. And again, I want to thank Armando for the work that he's been doing for us. I think having that small scale R&D capacity locally is really critically important. And lastly, we're open to working with any and all folk. We have a very collaborative approach on this. This is a way that we're going to be able to move this industry forward. Thank you all for your attention. I'll leave the questions up there and throw it open to the floor. Jean, back to you. Thank you.
Wow. Thanks so much, Neil. Let's open it up for questions or comments.
Neil,
Yes, Lex.
what about insect proteins?
There's a lot of excitement about insect proteins. And those of us in the industry, like every second day, there's a new story about a new insect protein operation. I haven't yet seen a model for that is going to scale in a way that really is going to make an impact. Because most of it is based on food scraps. And so that's people collecting from restaurants or from retailers collecting food scraps and using that as your insect protein feed. And I mean, we've got to be talking millions of tons here, or at least hundreds of thousands of tons for some sort of an industry like that to really gain traction. The best approach to this I've seen is that there is one company that is looking at partnering with Coors and taking the wort, the yeast essentially out of the vats of beer. Once they've brewed the beer and they've shipped the beer off to us, they take the rest of that dry matter and they feed that to the insect protein. So that's certainly scalable, and you can all take some joy as you sip on a beer this evening thinking, yeah, I'm helping move towards more sustainable aquaculture feeds through this. I don't know of other ways that might be more scalable, but perhaps there is potential. Other opinions? You also got your ear fairly close to the ground on insect proteins.
Yeah, I think one of the bigger challenges for us is inconsistency. So there tends to be a lot of variation in the outputs of insect proteins. And so I think to Neil's point around scalability, there are issues that they need to work through before it really becomes a viable alternative for us.
Neil, I have a quick question for you. What size feed mill would you consider would be ideal for like a research pilot scale?
Most of the work that we do at the moment is with USDA and US Fish and Wildlife Service. They have a feed mill in Bozeman, Montana, and they do on the 100 to 200 kilos per diet. And that's about the scale that would work for what we do with Kampachi. I think I defer to somebody who knows tilapia a little bit better to say, I think tilapia work very well on just a pelletized diet, I believe, Armando. And so maybe the facility that Armando has there might be adequate for other fish or something a little bit larger. But that's for the work that we've done with Kampachi has been in 100 or 200 kilos, allows you to run like a 3 or 4 months trial with the different diets.
I thought the one in Hilo was supposed to be pilot sized, not commercial sized. I'm not even sure what size it is. Maybe somebody else in the group knows exactly what that is, but I don't.
I think it was a ton or two per run, and that was difficult to get any takers for that. It was too much for us, and it's not enough for Dick or for anybody else that's doing commercial production. But again, there may be tilapia growers on the call that could weigh in. Did they have any engagement with the Hilo feed mill and why that didn't work for them?
Probably when we're talking about a pilot scale or research scale feed mill, we might be wishing something less than 100 tons per year. That will depend on the demand, but no larger than that probably. So just to have a rough idea of what we may be expecting or wishing in that regard.
Yeah, just for reference for people, this year we'll be at about 2,500 tons. At full biomass, we'll be at about 7,500 tons a year.
I had a just add to that, a big thank you. People often say, well, is there opportunity for a commercial mill here in Hawaii? I had a business partner when we were putting in a fish farm down in Mexico, and this question had come up, should we start our own feed mill here? And he had previously worked in Chile, and he had run the numbers on what it takes there to what scale do you need for a commercial mill to make sense. And that's in Chile, where you've got ready access to Peruvian fish meal and fish oil that are right there. And it had to be at least 70,000 tons a year to make commercial sense in Chile. So that's an order of magnitude more than what Dick is talking about there.
For the Niue farm that you're developing in Oahu, is that going to be in the state waters, or is that again in federal waters?
That one will be in state waters. Yeah, so we'll need permits through DLNR. Then you also need federal permits from EPA and Army Corps of Engineers.
Okay.
And the state coastal zone management permit and Coast Guard permit.
A couple of months.
Yeah, a month or two, we should have that.
Neil, one question. What do you think will be your requirements for research or test feeds per year for all the work that you're doing with your fish?
Yeah, for the research work, Armando, I think we'd like to be doing extruded feeds here. I mean, we're very grateful for you doing the diets with, for those that don't understand, a pelleted feed just sort of makes a compact pellet, and the extruder actually pushes it out. And I think the main difference here, Armando, correct me if I'm wrong, but an extruded feed, you can get a lot higher oil levels in an extruded feed and a bigger pellet. Which is what you need for the Kampachi and for the larger feeds, perhaps for the Niue. So for our research, we'd like to have an extruder that could be doing, as I said, 100 kilos or so for the Niue. Perhaps it would only just be 50 kilos. They're smaller fish, so it wouldn't need as much as the Kampachi, but so in the 50 to 100 to 200 kilo range for an extruder, such as they used to have one of these at Oceanic Institute when Warren Dominy was there. And I don't know what happened to that equipment. And perhaps somebody on the call can shed some light on that, because it would be really valuable to have that equipment available to the industry. So that would help us for the research work that we want to do when we are thinking about the commercial production of the moi and the Niue on the Oahu farm site. We're going to be buying that from the mainland. It's a question of scale and cost efficiency, and we just don't envision being able to produce the diets here in a way that was cost effective. But we are really excited about the potential to use some of the limu that we'd be growing there as a way to supplement the diets for the Niue, so that we could lower the feed conversion ratio on the Niue. So. Yeah. That answer your question, Armando?
Yes, Neil, thank you.
Other questions or comments for Neil?
Does anybody know what happened to the Oceanic Institute feed mill equipment? Anybody on the call? Is there anybody from OI on the call?
Neil, maybe we can connect with Sean to find out. Yeah, but it doesn't appear that anyone's on the call. But thank you so much for the discussion. Anyone have any final comments or questions? Well, I do have one question, I think, Neil. You know, with our collaborative, you know, people have been talking about feed for a long time, and we wondered about, what about a feed hui? You know, while we're waiting to scale or ramp up production on a feed mill, do you think there's interest in people, you know, combining what their needs are and saving on shipping and costs and things like that?
Thanks, Jen, because yeah, this is something that we've talked about in the aquaculture collaborative, just at a preliminary level. I'm not sure how, there's a separate group in the collaborative that's been talking about feed. I'm not sure how far those discussions have gone. But the way I see the industry here in Hawaii is that folk find a niche with their tilapia production or their catfish production or kampachi or seahorses or octopus or whatever it is. And generally it's a relatively small scale, but it's a niche. And so I don't see how it makes sense for a hui, a non-profit group, to collaborate to be bringing feed out here, or to be bringing the feed materials out here. There are companies that do Waimanalo feeds on Oahu. They will bring out, I'm not sure if they bring out container loads of feed or less container loads, but okay, they're making a profit doing that, but they're doing it a lot more efficiently than, I think, if you have a hui with troops running in all directions and people wanting this much feed here now from that producer and this much feed from that producer. I think the coordination challenges of that are overwhelming. You know, I hate to be a wet blanket on everything, but I think there are just some realities of being this scale. There's some beauty to this scale that folk can find those sorts of niches and produce for the local market, but it does make it really challenging. I defer to other folk here as well. Armando, Dick, or anybody else want to weigh in? Wayne, you've seen a little bit of aquaculture in your day. He's lurking in the background. You've got to have some opinion, Wayne.
Yeah, I think certainly from a Hawaiian perspective, you know, having a feed mill here, a collaborative feed mill approach would be useful. I think generally for me, you guys are the best ones in terms of, we're just looking at it from an investor perspective. I think alternative feeds and better feeds certainly are something that we would want to support. And, you know, I think one of the things I want to try and do in terms of the hatch perspective is to start attracting industry here, and also attracting those kind of that expertise and those kind of facilities to support more aquaculture independence here and grow it from here. And maybe bringing in expertise from, you know, one of our sponsors is Cargill, right? Why not dip into them and try and help certainly some of the connections we have with them in terms of supporting maybe some of the activities here. I think could be discussions we could move into to help make that happen.
All right.
The idea of a hui.
I'm with you. Yeah, I think it's a lot of logistics and a lot of work for the benefit that you gain. Right now, we're at 3 containers a week in our shipments of feed coming from basically Seattle to here. And, you know, we're not going to get more efficient if we get 4 containers, 5 containers. We're at the pricing that we're gonna get regardless of how big we get. So I think that the, as you've already said, the challenges outweigh the benefit.
Other questions, Jean?
Right, anyone? Any final comments? Well, thanks so much for sticking with us, everyone, and mahalo Neil for kicking off this important topic and sharing Oceanera's exciting and promising and comprehensive research. And thanks everyone for contributing to such a rich discussion. Please contact Neil to continue the conversation, and we will see you next month, and we'll definitely send you links to today's event. So thank you very much, everyone. Aloha.
Thank you.
Bye.
Where, so,